Now I will start column design with two-way bending. Two-way bending means bending will be about both axes, this axis and this axis. So there is an example, not example, problem from your book. This problem is 10.23. So this problem is a rectangular column. This is 16, this is 22. So it has bending about this axis and this axis, both axes. How do I know? There is a load, nominal load 400 kip, and it is acting EX 18, that means in this way 18, and EY 6, that means somewhere here. So somewhere here it has two-way eccentricity. So how to design this column? Uh, Again, so sometimes you might be given eccentricity, or sometimes you might be given moment. If moment is given, say if mx is given, if moment about x-axis is given, mnx, then divided by pn, you will get ex. So sometimes eccentricity is given, sometimes moment is given. So based on situation, you can find your E. Okay, that is a different story. Now, how to design? So design, there is no simple shortcut to design two-way bending. So there are two methods discussed in your book. One is very conservative, not so good method, but it will be in conservative side. Other one is little better method. So first I am going that conservative method. That is not good, it is over design, but still though it is good to understand. What is this method? This method is what we do here. We combine these two. That means we will make our ex plus ey. That means your e will be 8 plus 6 is 14 inch. Your u will be 14 inch, and then you will design as about y-axis. You will design about y-axis. That means your reinforcement all around. So this way you will design this way. So your eccentricity is about this way only. Why this way? Why about y-axis? Because my column is weaker about y-axis. That means it can have buckling this way very easily, not easily, because this way is so long. It's very difficult to buckle this way. This way it is easy. So we will design about y-axis. So our E by ace will be, E will be 14 and ace will be this dimension, because we are designing about y-axis. So E by ace is this, then gamma will be this way. That means 11 by 16. How much it is? Okay, let me design this problem full. It is 0.69. 14 by 16 is 0.875. Then what is your Kn? Kn is Pn Az A prime C. So Pn is given 400 kip. Az 16 times 22 inch square A prime C 4. Okay, if I do this calculation, 400 divided by 16 divided by 22 divided by 4, I got 0.29. Then what is my Rn? Rn is this Pn, excuse me, A prime C times E by ace. So it will be simply this times this, 0.29875. Okay, so 875, I got 0.25. So we got two numbers. So Kn 0.29, Rn 0.25. We will find a chart in your book. Okay, I need some space. Again, we are designing only y-axis because that is the weaker. Okay, see if I go to your book, find the chart. So I'm very close to the chart. My reinforcement is all around, yes, A prime C4, A Y60, yes, I got gamma here 0.6. Chart, graph 6, and graph 7. Okay, so I will save some room here. So when my gamma is 0.6, my rho z is how much? So 2925. So if I can 29 and is 25, 1, 2, 3, 4, 5. Again 2 Rn is 25, V is 25, and Kn 29. 29, that is at the middle. 25, 1, 2, 3, 4, 5. About 0.057, very high number. Then if my gamma is 0.7, if my gamma is 0.7, my rho z will be, so 25, 29, 1, 2, 3, 4. 4.3, so 0.043. Okay, what is my gamma? My gamma is 0.69, almost 0.7. So if I interpolate, when my gamma is 0.69, my rho z can be slightly more than this. That means say 0.045 is a good number based on this interpolation. So we got our rho z. Then what will be our reinforcement? 0.045 times my gross area. So if I do the calc, 0.045 times 16 times 22, so 15.84 inch square. So once we find our reinforcement, then choose your bars and place it. So design is done. Now this method is not a accurate method because we assumed both eccentricity about weaker axis. So this method is very conservative, very over designed. So this is not a good method. But if your structure, like if you have only one column or like huge column is not a problem, there that time you can use it. And also in the next method that I will discuss, this method will help you to understand that method, how that method is like more important or like better. So I will stop this video here. In this next video I will show you another method to design this beam. Again, before going there, here what I did, we combined this eccentricity and we assume that eccentricity E is about EY. That means EY. This will be about Y direction. We design everything along this direction so that my column will be safer, because one, I am adding this to, number two, I am designing about the weaker axis. If your column is square, then no problem, both ways same. So memorize or at least remember this value. Okay, I am writing this value so that when we will design the beam in the revised way, we will compare our amount of reinforcement. So thank you, and I will come back with the next video with new method. Thank you.